Hi guys, can you hear me? Yes, okay. Is anybody watching the Super Bowl today? Okay, okay. I'm gonna share my screen now. Okay, can you guys see my screen? Yes, alright, good. Okay, well, I think we will start class now. Okay, so today's class is gonna be on, do we get to watch the, no, I wish. Just kidding. That's not until 6:30, I think. Okay, anyway. So today we'll be talking about radicals. So I think you guys are already familiar with the sign. I hope so. This is like a normal radical sign. Um, so this is a little bit more complex if you add to the end. So normally when you see a radical sign, you just call it a square root. So like the square root of 4 is 2. And then what's assumed is you have that. There's a 2 there, the n is equal to 2, but that's just an assumption. And then when you have it as a 2, you can just leave it off. So uh, n is called the index of the radical. So if you have a root, it doesn't have to be a square root. It could be a cube root where the n is equal to 3, so it's equal to 3. And then like the cube root of 8 is equal to 2. So so like the square root of 2 is equal to 1.414. While the cube root of 2 is equal to 1.26. So how do you figure out radicals? So let's talk about that real quick. So basically radicals are opposites. Well, the concept of a radical, okay, so let's say the concept of a square root first. Square root would be the opposite of squared. So square root, so there's a 2 there. This is the polar opposite of squaring something. And then the cube root is the opposite of cubing something. So for example, the question, what number multiplied by itself is 25? So basically I'm asking x squared equals 25. And then we know that x is 5. So we can say the square root of 25 is equal to 5. So for square root, it's just asking like what multiplied by itself equals the number inside 25. So we know 5 multiplied by 5 is 25. So if we take this cube root of something, x, the question is what cubed equals x? And then this would equal y. So just what multiplied by itself would equal x? And then that's for cube root. To find the square root of a number, you take its square root. So like 25, you know 25 is equal to 5 squared, and then you take the square root of that and you get 5. So it's like inverse of squaring a number is taking its square root. So it's just square root is the opposite of squaring, and cube root is the opposite of cubing, and etc. in other words. Okay. So just to make sure you guys know your squares, let's do let's say number 2, number 4, and 11. So do 2, 4, and 11 because we don't have to do all of them. So out of these, just do 2, 4, and 11. Just to make sure you guys remember your roots. Wow, that's actually, huh, I didn't notice that. Okay, right, nice. The answer is just 2, 4, and 11. So if we look, I didn't notice that the number corresponded to the thing. Okay, so find the square root of 4. So it's just 2 multiplied by 2 is 4. So it's like 2 squared. You take the square root of that equals 2. There's a better way to explain it, but I'll explain it in a few minutes. And 4 is just like 16 is 4 squared, so it's 4. And then 121 is 11 squared. Okay. Okay, this helps explain it a little bit better. Okay, so you can put, so this is a radical expression. A is equal to a to the 1 over n. So you can change this into this. So like, for example, if you had the square root of 4, there's like an assumed 2 there because it's the square root, and you can write this as 4 to the power 1/2. So there's a better way to explain it. I'll explain it a few minutes later. So just remember that you can write this expression as this. So like, for example, if you took, let's say, 8 to the cube root, you can write this as 8 to the power 1/3. Right, so, and like 16 to the power 1/2. Okay, onwards. We'll come back for that. Okay, this is what I wanted to say first before we go back to that. Okay, so radical notation for the square root of n to the am. So this is basically, this helps like simplify radicals even if it's not like a complex radical. So let's explain it. So this expression right here is equal to a to the m over n. So first you can basically like take the m out and just let m encompass anything. So it's like a to the n to the power m, right? If we don't look at this first. So this is equal to this. You take the m out, and then I just said that if you can turn this into a to the 1 over n, this to the m. So that right here equals a to the m over n. So this is helpful when you're simplifying radicals. For example, if you had, we all know that the square root of 16 is 4. So because it's equal to 4 times 4. What you can do is you can write 16 as 4 squared, right? And then to the square root. And then you can continue writing this as I just said, 4, and then since this is an implied 2, to the 2 over 2, which equals 1. Or, sorry, which equals 4. Yeah, because 4 to the power 1 is equal to 4. And then for another example, let's say the cube root of 27. 27 is equal to 3 cubed, so let's write it as 3 cubed first. 3 cubed, and then this can be written as 3 to the 3 over 3, which is equal to 3. So go ahead and try number 3. All right, see if you, yeah, okay. Nice. The answer is 3. Nice job, guys. If you didn't know, 3 to the power 4 is equal to 81. It's just 9 squared, which 9 is equal to 3 squared, so it's 3 to the 4. And then you can write this as 3 to the 4 to the root of 4, which equals 3 to the 4 over 4, which equals 1. Okay, nice. Okay. Okay, let's try number 1. The cube root of 64. Right, nice job, guys. The answer is 4. If you didn't know, 4 to the cubed is equal to 64. What you could also have done is you could just simplify 64 all the way down, which is 2 to the 6. If you simplify 64 all the way down, you get 2 to the 6, which you can take the cube root of 2 to the 6, which is equal to 2 to the inside goes outside, 6 over 3, which is 2 squared, which is equal to 4. So just in case you didn't have 4 to the 3 is equal to 64 memorized, you can still, you know that 64 is equal to 2 to the 6 because you just factor that out, and then you take the cube root of that. So this, remember, equals this because there's that formula. X to the a b is equal to x to the a over b. Remember, we had, oh yeah, it's right here. A to the root of n over m is equal to a to the m over n. I don't know if you guys can see this right here. So this is a really important rule. A to the root at n over m. So basically you can take the m out and then m goes on the top and then n is 1 over n. So that's how that works. Okay. Okay, so here are some more rules. So get ready for a lot of rules because radicals always have a lot of rules. I'll zoom in a little bit so you can see the rules a little bit better. Okay. So first rule is, I'll write it here so you guys can see it, a to the n root n multiplied by b to the root n is equal to ab to the root n, or you can write it as ab to the power 1 over n. Just memorize this. It should be pretty self-explanatory because they're both under the same root. So like we know that square root of 5 times the square root of 2. Well, if you didn't already know this, square root of 2 is going to equal to the square root of 10. So basically, if they have the same, sorry, what's it called again? Sometimes I forget. If they have the index, it's called index. If they have the same index, so if you have square root, index is assumed too. If you have index, you can just put them together as long as it's multiplication. If it's addition, it doesn't actually work. So if it's multiplication, you can just multiply them together and put them under the same root. So they have to have the same index though. Same thing for division. If they have the same index, a to the root n over b to the root n. See, they have the same index of n. You can always write this as a over b to the root n. So multiplication and division, you can always make the root encompass everything as long as it's the same index. Okay. Next one we have is roots inside of roots. So these are actually really easy. They seem kind of complicated. So if you have the root n over the root m of x, this just basically you multiply n and m together. So then you have the root n m x. Okay. So try 1 through 4 and see if you can get it. Well, actually, first of all, let's just do number 1 and see if you can get number 1. It won't simplify all the way, so just simplify it as much as you can. So the root of 125. So put it in its simplest form. Okay, nice job to the people who got it. It's 5 root of 5. But I'll explain it since, sorry about that. It's a little bit complicated actually. if you don't know what to do. Okay, so what we're talking about is, I'll make it a little smaller so we write a little neater. Okay, so square root of 125, right? So we can use the things above here to kind of help us a little bit. So we know that 125 is what? 5 to the power 3, right? So we have the root of that. What we can do is, since this is the square root and it's not the cube root, we can't actually take 5 out, and we can't do anything other than that, so except for doing this. So we can actually write this as, we know that 5 has already a cube root, so we know it's going to have a square root too, right? So it's going to be 5 to the squared multiplied by 5. So this is, we can easily write it as this, right? So since we can write it as this, and then it gives us this, we can break this apart into the square root of 5 squared multiplied by the square root of 5. And then this comes out to be, so this becomes 5, and this is the root of 5. I'll explain it again since I didn't explain it too well just then. The 125 can be broken down into 5 cubed, and then 5 cubed can be broken down into 5 squared multiplied by 5. So why did I make it 5 squared? Because I knew since we have square root, this is the index of 2, I want to make something that has power of 2 come out. So since this is a power 3, I forced a power of 2, and then since it's multiplication and not addition, the 2 can actually break into, so this one breaks down here, and this one comes down here. And they're both under the same index, so that's why you can put them back together and break them up. And then the square root of this, square root of 25 is 5, and then 5 continues like that. So that's simplifying. I think I talk further on this later, so it's okay if you're confused now. I'll go back to it later. Okay, so remembering these up here, try number 2. And I drew it over here in case you can't see it. And then here are the formulas that'll help you. Ideally, this one will help you most. Okay, nice job. The answer is 2. That one's close. It's not what I'm looking for, but it's also correct. It's also 4 on the root 2. Nice. And root 4 to the cube. But I wanted you guys to use this formula right here. If you look at it, it's the same kind of setup. It's the root of a to the n and the root of b to the n, the same one. So then this can basically have a root together. So it's, we can make the root just big, 3 over 32 over 4. So this is equal to the root of the cube root of 8, which is equal to 2. So just remember, if they're division or multiplication and they have the same index, which is this number, you can basically put them together. Or you can take them apart as well. So it goes both ways. Okay. Okay, let's try number 4. The root of 125 plus the root of 45. So as like a little hint, it's not multiplication. This is addition. So you can't put them together since it's addition. Okay, good job to the people who got it. It's 8 to the root of 5. Nice. So how do you how do you make that?
Uh,
Oh, the square root thing? I'm not sure how you make that. Okay,
can you
I'm gonna mute someone real quick. Okay, sorry about that. Um, so how do you solve this? First of all, since it's not multiplication, you can't put it under the same root, so you just work on separate roots by themselves. So first off, we simplify 125 under the under square root. So we know that 125 is 5 to the power 3, which also equals 5 to the root 5, because we just talked about that. You can take the 5 squared out, and then you have another 5 because it's cubed, and then 5 comes out. And then plus 45 is actually equal to 9 times 5. So since 9 is 3 squared, you can take the 3 out. So this ends up equaling 5 to the root 5 plus 3 to the root 5. Since 9 is 3 squared, you can take that out because 3 square root is 9 square root is 3. So you can take that out and then that. And then now it's just simply, since they have the same radical, root 5, you just add them together. So 8 to the root 5. Okay. Yeah. So this is what I was kind of talking about simplifying radicals. I think MathCounts always asks this, like, show your answer in the simplest form, and then this would be you'd have to simplify the radical. So like we've been using this root of 125. This isn't in its simplest form because you can take something out. So this would be 5 to the 3, which equals 5 squared times 5. And if you take the root of that, the 5 comes out, and then the root of 5. So if you can simplify it even more, because this is definitely simpler than that. Right, the answer is 3 is 3. Nice. Yeah, nice. It is 3. I kind of skipped that one because I thought it was a little bit weird. Okay, but nice job. It is 3. Um, yeah, it's not in simplest form since this is considered simplest form because you can't do anything to the thing under the radical, and this is not because you can like continue to push. So this is equal to 5 to the 3. You can take the 5 squared out, and then the 5 remains. So that's that. Okay. Okay, and also a fraction under a radical is also not in simplest form. Um, hang on one second. Okay. Yeah. So a radicand is not in fractional form. So square root of 1/2 is not considered simplest form because you can simplify it so that there's not a fraction of the radical. So what you do is square root of 1/2. Actually, I explain this farther later, so I'm just going to skip this right now for now. Okay, we'll come back to that. First, we'll talk about rationalizing the denominator. So problems will always ask you to rationalize the denominator. So what does that mean? So that means that you cannot have a square root in the denominator. So whenever you have a square root in the denominator, if you try to rationalize the denominator, it means you make it so that the top still has a root, but the bottom is no longer the root of anything. So this is actually not that hard. There's just like 2 things you have to remember. So for the first one, we have the square root of a over the square root of b. And since the bottom has a root, we can rationalize the denominator. So anything, so x over x is always going to equal 1, right? As long as x isn't 0. So this is just like a universal truth, right? Anything, the same thing over the same thing is always equal 1. And then anything multiplied by 1 is always going to be itself, right? So we can use that on the square root of a over the square root of b. If it asks us to rationalize the denominator, all we do is multiply by 1, which can also be written as the square root of b over the square root of b. So this is the same thing. This equals the root of a over the root of b, because this is actually equal to 1. Because the root of b over the root of b is always going to equal to 1, right? Anything over itself is going to equal to 1. But this helps us because when we multiply it, we get the top becomes the root of ab, and the bottom becomes the root of b multiplied by the root of b, so the root of b squared, which is equals to b. So now we have successfully made it so that the denominator no longer has a radical. So just remember, multiply root of b, and then once you get this down, you don't even have to like go through this process. You can just know that, oh, if I multiply both the top and the bottom by the root of b, then this is going to be the root of ab, and this is going to be b, and then you can just skip this step right here. Okay, anyway, so for example, rationalize the denominator in the root of 3 over 4. So remember, the root of a over b equals the root of a over the root of b. So just remember that. And then rationalize the denominator. Right, the correct answer is square root of 3 over 2. This was kind of like a trick question. You don't actually have to really do anything. It's just the square root of 3 over the square root of 4. And then the square root of 4 is already 2, so it's just the square root of 3 over 2. You can also take the long way by multiplying both the top and the bottom by the square root of 4. So you get the root of 12 over 4. And then you can simplify the root of 12 into 2 on the root 3. Oh, class ends at 5. So yeah, 5. I don't know. It's 30 minutes from now. Class is an hour always. So 3 over 4. So the root of 3 over 2. Okay. Let's try something that actually is applicable. Okay, so simplify the radical for the root of 3 over 2. So root of 3 over 2. I think you forgot the square root there, Alex, but it still works. Nice job to everybody. It is the root of 6 over 2. So just really quickly, I'll explain it. The root of 3 over 2 is equal to root of 3 over the root of 2. Nice job, Anthony. Again, we can just skip the multiplying by root 2 over root 2 and just go straight to it and just be like square root of 3 multiplied by the square root of 2 over 2, because we already know that this works because you're just multiplying by 1, so you can just kind of like skip that step. And then square root of 2 multiplied by the square root of 2 is 2, so this ends up being the root of 6 over 2. So you don't really have to like, if you know that it's true, you can like skip the multiplying that and just go directly into it, just like to save time. As long as you know why it works, it works. Okay, so like this. Okay. Okay. Try this one. I don't know. I should probably explain this right. Okay. I'll just let you guys try this for like 2 minutes, or no, a minute, and then I will explain it. All right, nice. Nice to Robert and Golden. It is actually the square root of 3. Oh, wait. I think, Robert, you're just missing something. Yeah, you're missing the divided by 5. Okay. And Golden, that's kind of off as well. Huh. Okay. I don't think anybody's right, actually. Good try, though. Okay. I'll explain it. This one's a little bit, like, harder of a concept. I think you had the right idea, maybe? Or Robert has kind of the right idea. Okay, I'll explain it. It's okay. We'll use the whole board for this. So the question is, okay, so before doing this, you have to know one little like rule. It's a plus b multiplied by a minus b is equal to a squared minus b squared. So this is like one of the main things you have to know. If you don't know this, you can't really solve this. So I think this is like you should probably have this memorized already if you haven't. It's like a really big rule. It's just a squared minus b squared is equal to a plus b multiplied by a minus b. So how is this applicable in this? If your a is the square root of 3 and your b is the square root of 2, then when you square the square root of 3 and the square root of 2, they lose their radical. So like how would you go about solving this? So it's 1 over the square root of 3 plus the square root of 2, right? So we can multiply this by, in order to kind of like achieve this, since we want the bottom to look like this, because then there'll be no square roots. This has no square roots since it's always squared. This is the square root of 3 plus the square root of 2. So we multiply this by the square root of 3 minus the square root of 2. And the top has to be the square root of 3 minus the square root of 2. Because this equals 1, so we're not actually changing anything. Because this right here equals 1. Because it's the same thing over the same thing. Now this equals, so the top, you can't do anything with the top. But the bottom, if you look at the bottom, this becomes the square root of 3 plus the square root of 2 multiplied by the square root of 3 square root of 2. And then we can use this right here with this formula up here. And in this case, a is equal to the square root of 3, and then b is equal to the square root of 2, right? Do you see what's happened here? And then I'll explain it a second time if you guys don't get it. Since we now have this looking like this, we can simplify the bottom to be the square root of 3 squared minus the square root of 2 squared, which is just 3 minus 2, which is 1, and this is your end answer. Oh wait, so I made a mistake. There's actually no bottom. So nice job to Robert correcting me. I didn't look at the answer beforehand. So nice to this person who got it. So do you guys get this, or should I explain it a second time? I have no problem explaining it a second time. If you guys, anybody wants me to explain it a second time, I'll do it a second time. Because it's a really big problem. Anybody? No? Okay. Okay, if you guys insist. So just remember, you just have to remember a squared minus b squared is equal to a plus b multiplied by a minus b. Like, these problems always pop up somewhere. Like, I remember seeing these a lot, so and I didn't get it at first, so I had to have it explained a second time. So just remember, and then when you have a and b as radicals, using this is good because the radicals get squared off into something else. I don't know if I want to go into this part, so let's go back. I think I skipped a part at some point. Did I? Huh. Sorry, 1 second. Okay, just to prove that you guys know it. What is, so tell me what 2 over the square root of 5 plus, let's say, 3. So try and simplify this right here. Using the same thing what I taught you, simplify that. Right, nice job, guys. It is the square root of 5 minus the root of 3. Once you simplify it, you get something that looks like 2 multiplied by the root 5 minus the root 3 over 5 minus 3. Oops, 5 minus 3. So these 2's cancel out, so you just are left with the root of 5 minus the root of 3. Okay. And I actually did skip something. I'm trying to find it now. Okay, here we go. More examples with radicals. More practice. It's good. So let's first do 1. See if you guys can get 1. This is from Math Count Handbooks. the root of 12 multiplied by the root of 3. Right, nice. The answer is 6. It's just, since it's multiplication, you can put it under the same root, so 3 multiplied by 12, which is the root of 36, which is just 6. Okay, so let's try number 2. This is actually from a math counts competitions, not the handbook. Handbooks. The root of 128 plus the root of 72. So kind of like a hint, just factor and then work with them separately since it's addition and not multiplication. Right, nice job, guys. The answer is 14 on the root 2. Yeah, it's kind of easy to make mistakes sometimes. It's okay though. So like break it into 2 parts and work with each parts. The root of 128, if you factor it out, it comes out to be the root of 8 on the root 2 because 64 gets factored out and then you have 2 left. And then 72 becomes 6 on the root 2 because 36 gets factored out. And then now it's pretty easy. Since they have the same roots, you can just do 14 on the root 2. Okay, let's try number 3 now. Actually, 3 is more, I don't know. Okay, I'll let you guys do 3. Sorry. Wait, so there's like 2 ways to do this. You can just like bash at it, which is like just trying your hardest and then just like trying your hardest and then seeing if anything comes out and then just doing as many calculations as you can. Or you can just like try and see what you can pick out. So first off, you can just put everything under a big square root since it's all on the root 2. And nice job to the people who got 72 on the radical 2. These aren't exactly wrong, but they're not in simplest form. So you can put everything under the radical, so 54 times 32 times 6, right? And then before multiplying anything out, you can just kind of like try and break things down before you do anything. So for example, what the solutions do it a little bit different than I think it should be done. It's okay. So I'd factor everything out, so that'd be 3 to the 3, which is 27 times 2 times Sorry, 1 second. Two to the 5. Oops, that's a 5. And then times 2 times 3, right? So basically, I factored everything out. So 54 is equal to 27 times 2, so 3 squared times 2. 32 is equal to 2 to the power 5, and 6 is 2 to the power 3. And everything's a root. So now I just put everything together, so we get the root of 3 to the 4 multiplied by 2 to the 5, 6, 7. 7, right? And I simplify this. 3 to the 4 can hop out because it's actually 9 squared, so 9 comes out. And then 2 to the 7, 2 to the 6 can come out, so 8 can come out. And then since 2 to the 6 comes out, there's 1 2 left, so it's 2. And then from this, you get 72 on the root 2. Oh, yeah. Breaking it out first, yeah, so the solution that I have breaks it out first, and that also works very well. That's not wrong at all. Okay, yeah. So 2 ways to do it, both nice and easy. Okay. So let's do number 6, and then we'll end class a little bit early today. If you guys get it right, that is. So do number 6. It's from Math Counts Competitions. It's actually kind of a hard problem. So think about it, and then see if you can get it. So number 6, and then we're done. Right, okay, nice job, guys. The answer is 250. Yeah, I think you're just off by a factor of 2, so you might have just multiplied by 2 somewhere that you shouldn't have. But that's fine, no problem. Real quick, I'll explain it. Anything added together 4 times, so it's added 4, so you can just do 4 multiplied by 5 to the 6. And you take the square root of that. 4 becomes 2, and then 5 to the 6 becomes 5 to the 3, and then that equals 250. Which is your answer. Okay, so nice job, guys. Anyway, have a good rest of your weekend. Watch the Super Bowl if you want to. And I will see you guys next week, same time. Bye, guys.